Good day, everyone. Today we are going to learn about vacuum dewatered flooring, commonly called VDF flooring. It is an advanced concrete flooring technique widely used in industrial buildings and heavy-duty floors. Unlike ordinary concrete flooring, VDF removes excess water from fresh concrete using a vacuum system. This produces a floor that is stronger, denser, smoother, and more durable. In this lecture, we will understand its principle, advantages, construction process, equipment, applications, and how it differs from conventional concrete flooring. Vacuum dewatered flooring is a special concrete flooring method in which excess water is removed immediately after concrete is placed and compacted. A vacuum pump and filter mats are used for this purpose. This method solves the common problem of needing extra water for workability while still achieving high strength. Since unnecessary water is removed before the concrete hardens, the water-cement ratio is reduced. As a result, the concrete becomes stronger and more durable. VDF flooring is also known as tree-mix flooring, industrial flooring, or vacuum concrete. It is commonly used in factories, warehouses, airports, and commercial buildings where heavy loads are expected. Now let us understand the working principle of vacuum dewatered flooring. Fresh concrete always contains more water than required, because additional water improves workability and makes placing easier. However, after the concrete has been placed and compacted, much of this extra water is no longer needed. In the VDF method, a vacuum pump removes this excess water before the concrete starts setting. This reduces the effective water-cement ratio without affecting workability during placement. As a result, the concrete becomes denser, gains higher strength, has lower permeability, and develops better resistance to wear, shrinkage, and surface damage. Vacuum dewatered flooring provides several important benefits. It increases the compressive strength of concrete by nearly 30%. Young's modulus also increases by about 10 to 15%, making the floor stiffer and more durable. Since excess water is removed, permeability decreases, and water penetration becomes very low. The flooring also shows excellent abrasion resistance, making it suitable for areas with continuous vehicle movement. The process removes about 15 to 25% of the water present in fresh concrete. This reduces shrinkage cracks and improves the surface finish. Overall, VDF flooring offers longer service life, better durability, and lower maintenance compared to ordinary concrete floors. Let us now see how vacuum dewatered flooring is constructed. First, the sub-base is prepared and compacted properly. Next, side forms are fixed to obtain the required floor thickness. Fresh concrete is then placed and evenly spread. The double beam vibrator is used to compact and level the concrete surface. After vibration, vacuum mats and filter pads are placed over the concrete. The vacuum pump removes excess water from the concrete. Once dewatering is complete, the mats are removed and the surface is finished, using a power trowel to obtain a smooth finish. Finally, curing is carried out for at least 7 days, and groove cutting is done to control shrinkage cracks. Key equipment used in this process includes the screed vibrator for leveling, the vacuum pump for water extraction, the power trowel for surfacing, and the groove cutter for joint formation. 4 main components are used in the vacuum dewatered flooring system. The vacuum pump creates suction to remove excess water from fresh concrete. The removed water is collected in the water separator, preventing it from entering the pump. Filter pads are placed on the concrete surface to allow water to pass while preventing cement particles from being removed. These pads help maintain the quality and strength of concrete. Finally, the screed board vibrator is used to compact, level, and smooth the concrete before the vacuum process begins. All these components work together to produce a dense, strong, and high-quality concrete floor. Vacuum dewatered flooring is mainly used where floors are subjected to heavy traffic and continuous loading. It is commonly used in warehouses, industrial workshops, parking areas, and commercial complexes. It is also suitable for airport runways, aircraft hangars, railway platforms, harbors, bridges, walkways, hydropower plants, and canals. Because of its excellent wear resistance and smooth finish, VDF flooring performs well in places where forklifts, trucks, heavy machinery, or large numbers of people move continuously. These properties make it one of the preferred flooring systems for industrial and infrastructure projects. Let us compare conventional concrete flooring with vacuum dewatered flooring. In conventional flooring, the water-cement ratio remains high, which reduces strength and increases shrinkage. Surface dust formation is also common. In contrast, vacuum dewatered flooring removes excess water, resulting in a lower water-cement ratio. This produces higher surface strength, improved durability, lower permeability, and better abrasion resistance. Shrinkage cracks are significantly reduced, and the surface becomes smooth and dust-resistant. Although VDF requires special equipment and skilled labor, its superior performance and longer service life make it a better choice for industrial and heavy-duty concrete floors. To summarize, we learned that vacuum dewatered flooring, VDF, is a concrete flooring technique in which excess water is removed from freshly placed concrete using a vacuum pump and filter pads. This reduces the water-cement ratio and produces a stronger, denser, and more durable floor. We discussed its working principle, advantages such as higher strength, better wear resistance, lower permeability, and reduced shrinkage, and the construction process from concrete placement to vacuum treatment, finishing, and curing. We also studied the main equipment used and its applications in warehouses, factories, airports, parking areas, and railway platforms. Overall, VDF flooring provides a high-quality, long-lasting concrete surface suitable for heavy-duty applications.